so now we're going to graph cosine. And what we know about cosine, we know it starts at a max, period is 2 pi, ends in a max, halfway between, we're at a minimum, and to get to that minimum, we had to cross through some zeros. So, our graph should look like this for one cycle. And of course, we can, oopsie, not what I just did, we can go to the other side and sketch that as well. You shouldn't even have to think about graphing these, to be honest with you. If you have to think, then there's a problem. Okay, now we're doing the same thing that we did last time, and that is, notice that all of our values happen between -1 and 1. So we now need to figure out which angles do we have to look at, which lets every single value happen, and closest to the y-axis as possible. Now I have two choices. I have here and I have here. Now do we want to deal with negative angles or positive angles?
Positive angles, please.
So this is what we're going to choose. And notice that what we have here is quadrant 1. Uh-oh, too high up. Okay, I'll just make that a little bit lower. Here are our quadrant 1 angles, and here are our quadrant 2 angles.
Now, just talking about why are we using the positive ones and not the negative ones? The reason that we want to use the positive ones are, okay, every single one of these intervals needs to include quadrant 1. Because quadrant 1 is the spot where everything's positive. So in every situation, you're going to have quadrant 1 as part of your answers, okay? Whether it be tangent, cosine, sine, cosecant, cotangent, or secant, they're always going to have the 0 to pi over 2 interval included in their domain, okay? And so that section is always going to be part of our answer. The other part is, okay, well, where do we not repeat the values that are in quadrant 1? Well, for cosine, we don't repeat in quadrant 2. Quadrant 2 are new values, okay? For sine, they repeat in quadrant 2, so we had to use this stuff in quadrant 4. All right, we're never going to use this stuff in quadrant 3. That's like weird, okay? All right.
Okay. So, and once again, we have the same thing here. If the thing on the outside is what we're looking for. So ultimately, this property says we're looking for an angle. That's what's on the outside. This right here says we're looking for a value. Okay? Because we know the angle.
All right, good enough.
That says on the inside we want an angle. Once we have the angle, we want the cosine of the angle. Cosine of the angle. You can't see me pointing at the board, but I'm pointing at the board. Okay.
All right, so let's look at what we have here. This one says, all right, what's the cosine inverse of 1? Well, let's see. We have, where is, on the unit circle, where is the cosine equal to 1? Well, we know it's equal to 1 right here at 0.
At the angle is 0, and the coordinates are?
The coordinates are 1, 0. All right, so theta equals 0, and that's what I'm being asked for. I'm being asked for the cosine inverse is asking me for an angle, so the theta is 0.
Now, this is coterminal
with 2 pi. But I'm not going to use 2 pi because I'm looking for the cosine inverse, which is restricted to between 0 and pi.
It's not in our restricted interval, okay? So that's important. Again, you're going to have to memorize these. You have to know them. And really, if you know the graph, you can figure it out. Okay, now let's think about this a little bit more. Next one, we're looking for an angle, so we want an angle whose cosine is, that's what that -1 means, and we want to be negative square root of 2 over 2. That's what we're looking for. Once again, let's think about that. What quadrant do we have to place that in?
Well, we've got negative square root of 2 over 2. So the cosine is negative in quadrant 2. So that means my angle is going to be there. And let's see, this is the point negative square root of 2 over 2, comma square root of 2 over 2, which is 3
That
pi,
angle.
this angle, which is 3 pi over 4. All right, which is between 0 and pi.
So that worked. That's good. Is there another angle that has a negative cosine?
There's this one down here.
But
It's in quadrant 3.
again, it is true that that angle has a cosine of negative square root of 2 over 2. It's not in the right interval. Now this next one is weird because some of you would be tempted to use your calculator. But let's just take this one apart and look at it. What do you notice there? That is a positive value. Right?
Mm-hmm.
That is a positive value. So we want to know we are in, our theta then needs to be in quadrant 1. Wow, look at all that notation. Our angle is in quadrant 1. I should actually write a Q there. Okay. All right. Well, what are our angles in quadrant 1? One is 0 to pi over 2, right? Which in decimal approximation is 0 to 1.57. So does it work out that we are in our quadrant 1? Well, I don't know, because that is our value. These are our angles. Okay? We have to be in quadrant 1, so we want the angle whose cosine is in quadrant 1. Well, la-di-da. We calculate it.
So we do use our calculator.
Yeah, we have to. You're not going to have any problems that involve this. On our calculator we get, and I challenge you to go on your calculator, make sure you are in radians, and you're going to get this nice little answer, 1.430. And again, this is looking for an angle. So there's our angle. That doesn't look very much like an angle. It's not 1.430 degrees. It's 1.430 radians. And what do we know? In radians, there's our angles in quadrant 1. So is it in that interval? Is this between 0 and 1.57? Yes. So that means we have found the right angle. Okay?
All right, now these are fun.
We like them.
Okay, so first, these types of problems, you start from the middle and work your way out.
Yeah, think about it. You have to start from the inside and work your way inside out. So what's that first one? I see a -1. I see two negative ones. So which negative one's really important to us there?
This one right here.
And so what does that tell us we're looking for?
Find the angle whose sine is -1.
Okay.
So I'm going to draw my unit circle, okay? The sine of the angle whose angle is -1, okay, is the one that I care about. The sine is right here. Okay, so this is the point, let's see, 0, -1.
Okay, notice our sine, S-I-N-E, is -1 because that is the y value of the coordinate. So what is our angle there?
The angle I'm using is the negative angle, -pi over 2, because remember sine has the restriction -pi over 2 to pi over 2. So now that I know what this is, I'm going to look for the cosine of -pi over 2.
Hey, wait, we can do something really cool. Cosine's an even function.
Oh!
So the cosine of -pi over 2 is equal to the?
Cosine of pi over 2.
Cool. Now
Okay.
let's go find pi over 2 up there.
Now the pi over 2 is this thing right here, and this one has the coordinates 0, 1. So the cosine is 0.
Notice in this problem, once again, let's look at the things we had to look for. Do you see that our outside thing is asking for a cosine? So we are looking, our final answer is a value, not an angle, okay? The second thing we wanted to notice is, notice that here, our sine value is negative. okay? And since that sine value, the angle whose sine is -1, that means that our answer had to be, as Ms. Miller said, -pi/2 to 0, not including 0, because sine is not positive at 0. It's 0. Okay, there we go. So that's the thing we think about. Now let's look at the next one. It is really fun.
Oh, yes.
Because we've got 3 sections. So let's look. The first size, the first inside, what are we looking for? We are looking for an angle. We want an angle. Okay? The next thing, what are we looking for? We want the sine of that angle. The next thing, what are we looking for? We want an angle, I'm going to call it alpha, whose cosine is something. So we have to get all the way to that. So let's start with the inside one. Notice that our cosine is negative. What quadrant do we need to give our answer from, Mrs. Miller?
Quadrant 2.
Yep, so we need a quadrant 2 angle. All right, so here we go. Drawing our unit circle, thinking about -1/2 in quadrant 2. -1/2 in quadrant 2 makes that picture of our triangle. Our reference angle is pi over 3. There's our -1/2 for x, so this is -1/2. Square root of 3 over 2. And what is our angle in that quadrant?
It's 2 pi over 3.
2 pi over 3. The reference angle was pi over 3. The angle is 2 pi over 3. Next, we're now ready for sine. We want to find the sine of 2 pi over 3. Well, cool. We just plotted that point. And sine is our y value.
So it's square root of 3 over 2.
And next,
The cosine inverse of the square root of 3 over 2.
so we want the angle whose cosine is square root of 3 over 2.
Now, we can't use what we've been using so far because that one is not in our, wait. We need it to be in quadrant 1.
And we need the x, that's our cosine,
Yeah.
and that's square root of 3 over 2. That puts the long side of our reference triangle on the x-axis, doesn't it?
Mm-hmm.
And that makes our x-coordinate square root of 3 over 2, which corresponds to the y-coordinate 1/2. What angle is that?
That is pi over 6. All right, so now let's go to your first ET problem. These are pretty fast. They're pretty basic. So go to section 8.2 and do 2, 4, 8, 10, 28, and 31.
Also, be sure and do exactly like we did. Write the problem down and draw the triangles and think about it, okay? Each problem, draw your separate triangle and think about it.